What's up, everybody? So, I've often wondered when playing NBA 2K16, how much does your shot release timing actually affect the probability that you make or miss that shot? So, to try to determine an answer to this, I did a few tests. So, I started my testing by shooting 200 three-pointers where the yellow bar is exactly touching the white line and recording how many scored. So, by obtaining data for this best case yellow release, we can obtain a baseline from which we can compare worse releases to. I should probably note that I'm using Vinny Del Negro from the 97-98 Spurs as kind of a test subject, if you will. I chose him for a few reasons. First of all, he's a historic player, so I don't have to deal with the dynamic ratings always changing around, since I can't always test these all at one time. Another reason is that he doesn't have any shooting badges, so there's no other variables in there that could maybe mess up the data. So the next step here is to repeat this exact same method I've done, but only for the earliest possible release. Now if you look closely here, you'll realize that the earliest possible release without pump faking is exactly halfway between the edge of the shot meter and the middle white line. So for the final stage of the test, we'll be taking 200 more three-pointers, but this time with a release that's exactly halfway between the two we've just tested. This intermediate release will occur when the yellow bar fills up 75% of the way to the white line. Now obviously I had to eyeball this a little bit, but I tried to be as exact as I could. So for the results of these tests, I found that in the best case scenario, with the yellow bars touching the white line, 46.5% of those shots went in. And for the worst case, 33.5% went in. In the halfway release we tested at the end, 40% of those went in. Now clearly these shooting percentages will vary depending on the ratings of the shooter. Vinny Del Negro has an 81 3-point, I think, for what that's worth, but I'm only really using these numbers to try and extrapolate some conclusions, which will tell us how the shot meter functions. So this will probably be easier to explain if we look at a graph. Yay, graphs. So as I said earlier in the video, we'll be using the best case scenario, the release you see on the far right of the graph, as a baseline to compare how much worse everything is compared to that. So after doing some fairly simple math, I found that the worst case release has a 28% less chance of going in, and the intermediate release has a 14% less chance. A nice thing about these data points is they seem to be approximately linear, so you can kind of approximate the releases in between these three just by looking at the graph and seeing what point it corresponds to. So hopefully I didn't bore you too much with the math and graphs and all that fun stuff. But I think the key takeaway here is that your shot release can negatively affect your shot percentage by as much as 28%, or more likely in the range of 14 or 15%, given that probably all of us aren't that bad at timing. Maybe some of you are, I don't know. Another useful bit of information we can obtain from these tests is that even a good shooter under a best case release will only hit about 47% of their open shots. Now I know this seems pretty minuscule compared to NBA 2K15 where you could virtually hit every single open shot, but off the top of my head, I think it's about similar to what a good three-point shooter in the NBA would hit when left open. Now I know this video leaves quite a few unanswered questions like, does the shot meter behave the same way for mid-range? Does it behave the same way for good and bad shooters? What if someone's contesting my shot? These questions are a bit beyond the scope of this particular video, but I'll definitely be sure to test them at a later date when I have more time to. So if you've made it this far, thank you very much for watching the video. I'm sorry if my commentary is a bit lackluster at times, but I hope at least I was able to teach you something.